Imagine a seemingly stable weather pattern, like a calm summer, suddenly snapping into an unprecedented deep freeze. This dramatic atmospheric shift isn't random. It results from immense, unseen forces stretching our global weather systems. Our planet's atmosphere possesses a hidden elasticity, capable of storing and releasing incredible amounts of energy. Understanding this rubber band effect reveals why our weather can transform so violently and unpredictably. Earth's atmosphere isn't merely a static blanket shielding us. It's a dynamic, fluid ocean of air. This intricate system constantly churns, driven by fundamental differences in temperature, pressure, and Earth's rotation. These interacting forces create the vast, complex weather patterns that shape every aspect of our daily existence. While many atmospheric patterns follow predictable courses, others display surprising, sudden deviations from the norm. Think of the enormous pressure gradients and warm air masses constantly battling colder, denser air across the globe. The planet's rotation, known as the Coriolis effect, subtly deflects these moving air currents, creating swirling vortices. These fundamental interactions generate everything from gentle breezes to destructive hurricanes and persistent heat waves. Why should you care about these atmospheric mechanics? They directly dictate the air you breathe and the rain you receive. Understanding these underlying principles is crucial for comprehending Earth's powerful and often surprising climate variability. They explain why some regions experience prolonged droughts while others endure relentless, record-breaking torrential downpours. These hidden atmospheric dynamics ultimately govern the very habitability of diverse regions across our magnificent blue planet. The rubber band effect describes how large-scale atmospheric patterns can stretch and then rapidly recoil. A prime example is the powerful jet stream, a high-altitude river of fast-moving air encircling our planet. This ribbon of wind typically flows west to east, acting like a railway track, guiding major weather systems. Its strength and direction are primarily driven by the stark temperature contrast between polar and warmer temperate air masses. Imagine this jet stream as a giant, taut rubber band stretched across the northern hemisphere, usually maintaining a straight path. But that's not the strangest part about this atmospheric highway, as its behavior can profoundly change. Major mountain ranges, or persistent pressure systems, often push this atmospheric rubber band sideways. This creates significant waves, or meanders in the jet stream, causing it to become dramatically wavy or meridional. Picture pushing a stretched rubber band off-center. It begins to oscillate, creating large, sweeping movements. These deep atmospheric waves can pull incredibly warm air far north, or frigid cold air unusually far south. This stretching action builds up significant potential energy within the atmosphere, just like a tightly pulled rubber band. The extended, wavy patterns can persist for days or even weeks, leading to prolonged periods of extreme weather. Wait until you hear what comes next regarding the dramatic release of this stored atmospheric tension. When this atmospheric rubber band snaps back, these stretched patterns recoil quickly and often violently. This rapid recoil frequently leads to sudden, dramatic shifts in local and regional weather, almost like an atmospheric whiplash. For instance, a persistent cold snap might abruptly transition into an intense, record-breaking regional heatwave. Conversely, a region suffering prolonged drought could suddenly experience torrential, overwhelming deluges of rain. Sometimes, persistent high or low pressure systems, called blocking patterns, act like knots in this atmospheric rubber band. These blocks effectively halt the normal west-to-east flow, diverting the jet stream around them in extreme loops. This diversion forces weather systems to stall, causing prolonged periods of either dry, sunny conditions or relentless precipitation. And then something unexpected happened, as these powerful blocking patterns eventually broke down, releasing tension. When these atmospheric blocks finally dissipate, the stored energy releases, allowing the jet stream to quickly reorganize. This rapid reorganization of the atmospheric rubber band can trigger cascading weather effects across entire continents. Persistent heat domes, trapping sweltering air over vast areas, are often products of a stretched jet stream. Similarly, extended periods of heavy, localized snowfalls can result from a stuck or severely contorted atmospheric rubber band. The sudden release of this built-up tension then dramatically reshapes regional forecasts, often surprising meteorologists and residents. This atmospheric rubber band effect has profound, far-reaching real-world consequences extending beyond daily weather forecasts. It directly influences agricultural cycles, determining crop yields through unexpected frosts, intense heat waves, or damaging floods. Energy demands fluctuate wildly, placing immense strain on power grids during sudden, extreme cold, or sweltering heat. Urban infrastructure faces significant challenges from rapid transitions between prolonged droughts and sudden, overwhelming deluges. Understanding these dynamic atmospheric elasticity patterns is absolutely crucial for effective disaster preparedness and mitigation. Imagine entire communities needing to prepare for both severe wildfires and then devastating floods within a single season. These rapid, dramatic weather shifts also profoundly impact natural ecosystems, stressing wildlife and delicate plant life cycles. The rubber band analogy helps scientists develop more accurate models to predict these potential, large-scale swings. Improved predictive capabilities allow for better early warnings, ultimately saving countless lives and protecting valuable property. For instance, anticipating a sudden shift from prolonged drought to heavy rainfall enables proactive water resource management. This phenomenon highlights the intricate, interconnected nature of our global atmospheric and weather systems. Every stretch and recoil of this invisible rubber band ripples across vast distances, affecting countless human lives. This dynamic, invisible atmospheric elasticity silently shapes our very existence and our interactions with the natural world. It underscores the constant, powerful forces governing Earth's climate, demanding our continued study and respect. The atmosphere's rubber band effect reveals a fascinating, hidden dynamism driving our incredibly diverse and powerful weather. It's a constant, intricate dance of stretching and recoiling, silently orchestrating the dramatic changes shaping the world around us. By understanding this complex atmospheric elasticity, we gain deeper insight into Earth's magnificent and often surprising powerful systems. If you found this fascinating exploration mind-blowing, remember to subscribe for more incredible stories like this. And let me know in the comments what other hidden forces of nature intrigue you most in our amazing world.